Welcome to our guide on incorporating AI and adaptive technologies in education, where we explore how intelligent personalization, automated feedback, and adaptive supports can transform learning. This presentation will walk you through evidence-based strategies, practical implementations, and measurable outcomes so institutions can understand both the promise and the pragmatic steps for scaling AI to improve student success. This slide previews the roadmap for navigating AI in education, from the broad revolution reshaping classrooms to adaptive learning platforms, automated feedback systems, AI-powered student support, implementation, roadmaps, and methods for measuring success. Think of this as your high-level map. Each section will unpack why change is needed, how the tech works, and what outcomes institutions can realistically expect. Now we open Chapter 1 to examine the AI education revolution, looking at the current landscape and the opportunities ahead. In this chapter, we'll set the context. Why educators and institutions are pushed toward innovation, where gaps exist in traditional models, and how early AI adopters are already seeing meaningful gains in learning and operational efficiency. Educators face mounting pressures, large class sizes, and administrative tasks eat into teaching time. And many students expect round-the-clock support that traditional systems can't deliver. This slide highlights that mismatch and introduces how AI can help by personalizing instruction, automating routine work, and delivering analytics that surface where learners need help, ultimately addressing burnout and closing the student experience gap. Here we look at adoption trends. The chart compares current deployment of tools like adaptive platforms, chatbots, NLP, and analytics against their much larger future potential, showing room to scale. On the right, student expectations and global uptake underscore growing demand for 24/7 personalized experiences, and projections suggest adoption could reach widely across institutions by the end of the decade. Chapter 2 shifts focus to adaptive learning technologies and how they personalize education at scale. This section will unpack the building blocks that allow systems to match content and pacing to individual learners, and why that capability matters for both struggling and advanced students as institutions aim to deliver more equitable and effective learning. Adaptive systems rely on a layered technology stack, a learner model that updates profiles from assessments and behavior, a domain model organizing curriculum and sequencing, and an adaptation model that selects resources in real time. Underneath, methods like supervised and unsupervised learning and reinforcement techniques refine personalization so learners receive targeted practice and instructors gain actionable insights. This slide highlights real-world impact and research evidence. Meta-analyses show meaningful learning gains and effect sizes, indicating medium to large cognitive improvements, while case studies like adaptive math and data science platforms report 2 to 3-fold learning boosts. Practically, adaptive systems often translate into several months of additional learning and measurable increases in student achievement and engagement. Across the market, a handful of platforms stand out for different needs. Some excel at math and science diagnostics, others offer gamified language practice, and enterprise solutions support deep personalization across skills. Each platform balances strengths like real-time adaptation and content coverage against trade-offs like implementation complexity or custom content needs, so choosing a solution depends on institutional priorities. Chapter 3 introduces automated feedback systems and why closing the feedback loop matters. In this section, we'll explore how delayed or limited feedback undermines learning, how automation can restore timely guidance, and how those improvements free educators to focus on mentoring and higher-value interactions rather than repetitive grading tasks. Traditional feedback processes often create delays that let misconceptions persist, and faculty face heavy grading workloads that limit personalized mentoring. This slide lays out the cascading impacts: lost learning moments, compounding knowledge gaps, eroded student confidence, and increased burnout, and emphasizes why faster, actionable feedback is central to improving learning outcomes. AI-powered feedback systems address these issues by continuously tracking progress, delivering immediate, actionable feedback on assessments, and surfacing personalized insights for both learners and instructors. The model supports a three-tier feedback approach: instant corrective feedback, detailed post-assessment summaries, and longitudinal progress tracking, helping students correct errors sooner and sustain momentum over time. Automated assessment tools now reach high levels of consistency for essays, short responses, and creative work, while also reducing faculty workload and standardizing feedback across classes. Technologies like convolutional and recurrent networks and transformer architectures enable this capability, and most importantly, AI is framed as augmentation, supporting human judgment, not replacing it, and enabling richer, more scalable feedback. Chapter 4 focuses on AI-powered student support, showing how institutions can offer personalized assistance 24/7. This section explores tutoring systems, chatbots, and early warning analytics that together extend advising capacity, improve access to services, and proactively guide at-risk students before issues escalate. Intelligent tutoring systems emulate human guidance by answering questions instantly, offering multi-approach explanations, adapting practice problems in real time, and providing tailored feedback. These systems scale tutoring far beyond human capacity, integrate with existing learning platforms, and evidence suggests they can deliver several months of additional learning compared to traditional instruction. AI chatbots are transforming student services by handling admissions, queries, course registration help, and complex financial aid guidance in multiple languages and channels. They generate dynamic documents, protect privacy, and significantly reduce routine advisor workload, letting human staff concentrate on mentoring and high-value interventions, while students get quick, consistent support anytime. Predictive analytics detect at-risk learners by analyzing grades, engagement metrics, attendance, and behavioral signals, then trigger targeted interventions. By combining automated alerts, personalized outreach, resource recommendations, and peer networks, institutions can improve retention and completion, with many programs reporting marked gains in student persistence and timely support. Chapter 5 walks through the implementation roadmap, shifting from strategy to execution and addressing the practical barriers institutions face when bringing AI into classrooms. This chapter focuses on planning, resourcing, training, and governance needed to move from pilots to sustainable scale. Common barriers include high upfront costs, limited devices or infrastructure, and gaps in faculty, knowledge, and training. This slide pairs a chart of top obstacles with practical solutions: phased device investments, IT partnerships, comprehensive faculty development, and creative financing strategies like pilots and public-private partnerships to lower risk and build momentum. Building faculty readiness means scaffolded training, awareness sessions to introduce concepts, hands-on workshops using real course materials, peer practice labs for shared learning, and reflective debriefs with micro-credentials to validate skills. Coupled with training modules on efficiency, engagement, and equity, this learning by doing approach turns curiosity into practical classroom capability. Responsible implementation requires protecting student data through FERPA and GDPR-aligned practices, minimizing collection, and enforcing encryption and access controls. Transparency and consent are essential, and institutions must treat AI as augmentation, maintaining human oversight, addressing algorithmic bias through audits and diverse datasets, and codifying ethical guidelines for fair, accountable use. Chapter 6 turns to measuring success, focusing on ROI and learning outcomes so stakeholders can evaluate impact and make data-driven decisions. This section covers financial modeling, academic metrics, and the indicators that show whether AI investments are producing the intended student and operational benefits. A mid-size institution example illustrates how modest costs for platforms and integration can yield large returns via improved retention and efficiency, with benefits far outpacing annual costs and short payback periods. The chart here summarizes retention gains and projected financial impact. emphasizing that careful implementation can produce measurable, sustainable value. Evidence-based outcomes show cognitive gains and academic improvements, meta-analyses report positive effect sizes, and students using adaptive systems often achieve the equivalent of several months of extra learning. AI personalized approaches drive higher engagement, faster cycles of feedback, and, in many cases, 2 to 3-fold gains compared to traditional instruction, reinforcing the case for scaling effective tools. Looking ahead, emerging trends include emotional AI that senses engagement and adapts instruction, AI-powered VR, AR offering immersive learning with higher retention, and content generation tools that streamline curriculum creation. Additional shifts like microlearning, real-time translation, and advanced analytics point to a future where personalized, inclusive education becomes increasingly scalable and effective. In closing, transforming education through AI is not merely a technology upgrade, but a fundamental shift in teaching and learning. By embracing adaptive technologies, automated feedback, and personalized support, institutions can create an ecosystem where every student receives the attention they need, outcomes improve measurably, and the central question becomes how quickly and equitably we scale these innovations.